All right, here we go. So this is going to be about the chapter 7 information about scatterplots and correlation coefficients. Now, what's really nice is that everything we're going to talk about for chapter 7, so the next 2 days this week, a couple of days next week, then we'll move into chapter 8, it just builds on this. All right, so I'm not that worried about the students that are absent currently because of the Kairos retreat, because we're going to continue to talk about a lot of the same stuff. Obviously, we're going to do more when we get to chapter 8, but ultimately, this stuff is all linked. All right, so we are moving into a new unit. All right, we're moving into a new unit where we're going to focus on a linear relationship between two quantitative variables. I'm going to say that again. We're going to focus on the linear relationship between two quantitative variables. And the graphical display we're going to use is a scatter plot. All right, so I'll show you with your calculator today how to make a scatter plot, and then we'll spend the next couple of weeks talking about what we can say about that scatter plot. All right, so let's start by looking at the very thing that you just wrote, because I believe you had to write down the last bullet point. All right, do you remember our mantra when we were looking at a histogram? How do we describe a histogram? Excellent. So that's like tattooed here. On the other bicep, you should have tattooed direction, form, and strength. Check it out. Direction, form, and strength. So whenever you're talking about the association between two quantitative variables, I'm expecting you to comment on direction, that's positive or negative, form, linear, not linear, and strength, strong, moderate, weak. Okay? I'm looking for all those things. Roberto.
What is it in unusual features?
Possible outliers. Okay? Always commenting on that. Any questions so far?
No.
All right, let's keep going. All right, so let's start with direction. All right, if you look at direction, again, this is where I'm thinking about, is it positive or negative? And because of what's going on right now in the United States, we have hurricanes approaching everywhere, it feels like. I have put up some information about hurricanes and a scatter plot about the prediction error from 1970 until more recent, about 2005. And you can notice that as the years have gone on, our models have become better. We are predicting the route of these hurricanes more accurately than they were in the 70s. Which is why now, even though it feels like a lot of damage happens with these hurricanes, which absolutely they're projecting $170 billion worth of damage with this hurricane approaching the Carolinas. Yeah, that would be the most ever. That's still less than it would be if we weren't using the technology for the models about where these hurricanes are going. Marcelo, question? Yes, to be more than Harvey. I don't know what Harvey was. I think we got into the 100 billion range. Exactly. It feels like play money at that point, right? All right. So again, if you look at this one, do you see how it's kind of moving from the top left to the bottom right? That would mean it has a negative direction. A negative direction. So if it was moving the other way, bottom left to top right, that would be a positive direction. All right, think about your algebra class with the slope of a line. That's the idea here. Okay, if you remember slope of a line, positive and negative, it's the same idea. Yes. Good question. If you're saying like if it was just kind of mostly horizontal, then you could say something like it doesn't look positive or negative. You could say constant. That's fine.
Can you say neutral?
You can say neutral. That's fine.
Do you have to say like roughly or like?
Roughly is not a bad word.
Wait, roughly?
No, like roughly positive? Is that what you mean?
I wouldn't say, I probably wouldn't say roughly positive. I think you're trying to find a weasel word, right? I'd say it looks approximately positive, something like that. I mean, if you say positive, here's the thing about this, guys. Kind of like with the shape center spread, you're going to say all this stuff, but we're going to run some statistics to back it up. So once you run the statistics, then you can go change your idea. If you're like, oh, that's actually saying something else. Okay, like later on, we're going to do strength, and you're going to decide if it's strong, weak, or moderate, and then you might actually calculate the thing that will tell you how strong it is, and you can change your mind. And you're not like, You don't have to stay in that idea. Yeah.
Wait, so like, let's say in the 2000s, if you still had like, let's say 4 or 5 dots in the 625, would that be considered an outlier?
Maybe you could say something's unusual. If it was going like this, then you might be getting into the idea that maybe it's showing something that's not necessarily linear. You might be showing a curve, but that's going into not direction, that's going into form. Okay, so form is talking about the actual kind of bend that you see. So I put this scatter plot here on the right to show you this. Do you guys kind of see the bend in this one?
Yeah.
All right, I would say it has a bend or it's showing some kind of curve. All right, that doesn't look linear. Now the whole point of pretty much the next month is going to be about linear relationships. So if it's not linear, can we do what we want to do? No. All this stuff I'm going to teach you to do over the next few weeks, we can't do any of it if it's not showing a linear form, a linear relationship.
But there's something we could do with that.
You're going to find out when we get to chapter 10 that we're going to, and it is in the very last part of this chapter. It mentions it, but just briefly. We're going to do something called re-expression. All right, we're going to re-express, aka change. We're going to change either one or both variables so we can make it look linear.
Using like.
It's right here. I put it right here. We can learn to re-express it right here. That'll be chapter 10. All right, because none of this is worthwhile if it's not linear, or at least somewhat linear. All right, so that's form.
Oh,
I'm sorry, George. Yes.
for like, in this topic, is skewness also here to be a...
No more skewness. Skewness is just looking at one histogram about one quantitative variable. We're looking at the relationship between two, so it's kind of completely different. Think like we're doing a new unit, like completely different now. Okay, so strength. Now for strength, anytime you see your scatter plot, your dots tightly together, all right, really close together, going in a direction, positive or negative, okay, that looks linear, it will be strong. So that means that your correlation coefficient, which we'll talk about later on in this lecture, that's the letter R, is going to be strong, close to 1 or -1. Okay? Now, if you have like this, you guys see it looks like kind of like a cloud. There's a lot of scatter. This is not really strong at all because I don't really see either the form, it doesn't look linear, and doesn't look like there's any discernible idea of what's going on. So this would be weak. Anything in between, you're going to use moderate. Now, I'll show you guys when we get to calculating what kind of threshold I use for when you calculate the correlation coefficient, what that's going to do in terms of how strong I think it is or how weak I think it is. All right? I'm glad we made it to this chapter because I've had many of you in this class already use the word correlation, and I have never used that word until today. All right, we can finally use that word. A lot of you guys are using that word because it's used in society, but in stats, it's specifically for the linear relationship between two quantitative variables. So like I'm in meetings constantly at this school and people are using the word correlation. I'm like, oh, shouldn't use it. But I don't say it. I know. Take the high road. Thanks. The one on the left, what do you think? They're really tight, so yeah, strong.
Oh, I thought that was like a...
No. So if it was like...
That's like moderate.
Yeah, I'm trying to give you a moderate one where you can see the direction, but they're not really tight. Yeah.
Does that have to do with like how big the circle is?
No, that's just the problem I found. No, it has nothing to do with the size of the dot. Good question. That's a good question. It has nothing to do with the size of the dot, just how tightly clustered they are, Roberto. Okay? All right, now, let's talk about the unusual features real quick. So again, this would be looking for anything that you find unusual. Like George, you mentioned, what if in that hurricane one, it had then gone back up? Like that's confusing. We're getting better and better and more precise every decade. And then what happened in 2005? Why was our prediction so wrong? You know, and that could happen, right? Maybe with Hurricane Katrina, we really thought it was going to go this way, and then it just shifted the last second. That does happen. Okay? So we will talk about outliers again. That is going to be a carryover from the previous unit. Now, in terms of the variables, you'll notice up here, we're not saying independent and dependent. You guys see how there are no words here that say independent and dependent variables? Bless you. We're going to say explanatory and response. Explanatory and response. So get used to that vocab. The idea is the explanatory, think about when you say explanatory is the X. Explanatory is your X, it will go on the X-axis. And your response, your Y, will go on the Y-axis. Okay? Now, I'll teach you guys this probably at the end of the day today. But you always want to say a sentence about how you want to set up the scatter plot. Because the AP exam is not going to say, hey, this one explains that one. You have to decide. Okay? So we will talk about what we think is happening when we get to an example. We get to set up the scatter plot how we want. And we'll look different based on that. All right, now we're finally here. We made it. We made it. Sorry for those listening. That was quite loud. We made it to correlation. Now, I told you guys that this word in statistics is referred for how strong or how weak the linear relationship is between two quantitative variables. So I told you guys that this word is used all the time at meetings around the world when it's not supposed to be, but it's used because socially we use it, even though we're using it incorrectly. Like, for example, when I'm in meetings, people will be talking about categorical variables and how they are related, and they'll use the word correlation. They shouldn't use that word. They should use the word association. The word association is always okay. How are they associated? How are they related? If it's quantitative and it's linearly, then you can say correlation. Yeah, Tanya.
So if you're on the AP exam, you have to use association or correlation, right?
Basically, if I haven't decided that it's two quantitative variables and it's linear, I'm not using that word. If I tell the AP exam these are two quantitative variables, there's a linear relationship between them, I'm going to look at the correlation. All right? No, it's okay to use the word association until you decide that there has a linear relationship and they're two quantitative variables. So they won't take points off. You'll notice that when I write down answers, before I check some stuff, I'm going to use the word association. Because I may not know. It's always okay to use association. Now, you'll notice these conditions here. This is the idea before you can use the word correlation. Okay? We already said they have to be quantitative. So what am I looking for to make sure they're quantitative? What am I looking for? Units. Very good. I'm looking for units. If I can't think of the units, then maybe it's not quantitative. Straight enough condition, that's just a way of saying, is it linear? Does it look linear when you look at the scatter plot? Okay? You decide. And then, are there any outliers? What I usually tell students, like we did before, if you think something's an outlier, report all your stuff with it included, report all your stuff with it excluded, and do it twice, and see if there's a big difference. If there's no real big change, just leave it in. If there's a big difference, then you might want to do some more research. What's going on with that interesting point? All right. Now, some properties. I've already mentioned a few of these. It's on the backside. Correlation coefficient, the letter R, is between -1 and 1, always. So if somebody says the correlation coefficient is 2.4, you're thinking, what? Something's wrong. It's always between -1 and 1. The closer you are to -1 and +1, the stronger the linear relationship is. What if your letter R, your correlation coefficient, is close to 0? Then it's going to be, if it's close to 0, it's going to be weak. If it's close to 0, it'll be weak. If it's close to the extremes, -1 and 1. So the way I think of it is like this. If it's +1, then it's going to be in a perfectly straight line. This would be correlation coefficient of R is 1. Okay? Be the same thing, but it'd be a negative slope. Now, those usually don't happen in real life, so we probably won't ever see that. But the idea is the closer you are to the extremes, the stronger that linear relationship is. Linear relationship. Okay? Now, what's interesting is that if you decide to put a variable on the x-axis that's different than what I decide, so you have different x and y's, the correlation coefficient is the same. It's not changed. Okay, so they love that question on the AP exam, where they say, what if I change the x and the y and I switch them? And like, what happens to the correlation coefficient? It doesn't change. All right, so don't get tripped up on that question. It doesn't change. It's kind of like z-scores. Remember z-scores? How we can do all that stuff and the z-score is unchanged? Same idea. You guys hopefully saw that in the packet before the test. There are no units for correlation coefficient. There are no units.
Hey, but wasn't that a,
Say it again?
wasn't that a rule for like the farm?
No. That's that the variables have units.
Oh.
But the correlation coefficient, which I calculate, it's a statistic, that has no units. And what you might be thinking is, that sounds a lot like standardized z-scores. The idea is, guys, if you read the textbook, it shows you how the computer calculates R. And guess what they use? Z-scores.
Wow.
They use z-scores to do this. All right? So if you're curious as to how they calculate it, there's a few pages in the book that tells you how they do it. You don't need to know that for the AP exam.
So does that really compare them?
Exactly. They might even though they might be the same units, they still are two different things. So we want to compare them. The way to do that is z-scores. All right. Almost there. Now, this is one of the biggest things that you're going to read over the next few weeks. We're going to say that two quantitative variables are correlated, that they have a relationship. But just because we say that doesn't mean there's a cause and effect relationship. And this is my favorite example. So I want you to listen to this example. It's my favorite example. Okay? I have two variables. All right? Two variables. Ready? Average life expectancy in a country. All right? You guys all have that in your brain? On average, how long do people live in a country? Okay? That's quantitative. The unit is years. The other variable is number of TVs per household. Number of TVs per household. If I looked at those, there would be a relationship. Number of TVs per household. An average life expectancy. And many of you are like, what? Wait, what? That's true. If I looked at countries around the world, there would be a positive relationship between those two variables.
And how,
Why the heck is that?
Because, like, if you can afford more TV.
The idea is there is a lurking variable. That was my lurk. Is that good? Okay? There's a lurking variable. And the lurking variable is many different ways you can describe it, but it's the socioeconomic status of that country. The more you can afford things like TVs and cars, usually you can afford things like healthcare. Okay? So there's a lurking variable that's driving that. So somebody was like, whoa, cool! We should start sending TVs to countries that have low life expectancies. Here's more TVs, you'll live longer. And many of you are like, wait, what? And it's because of the lurking variable. All right? So just be careful. That's why you never want to say that even if they're related, don't say there's a cause and effect relationship. We'll show you in chapter 13 when we run experiments what you have to do with an experiment to say cause and effect. Right? Which is why for decades, people were fighting the idea that smoking cigarettes causes lung cancer. They were fighting it. Somebody even said that lung cancer causes you to smoke cigarettes. Yes, in Congress in the 70s. It's a thing. Google it. It took forever. You know those things, if you've ever bought cigarettes, hopefully you haven't, but if you've ever bought cigarettes, it has like a skull and crossbones that says smoking this could cause you to die, something like that. It took decades to get that thing on there. Decades. Experiments. We'll talk about it in a few months. Oh, we'll get to that, right? You want to say, you're 12, you're going to smoke cigarettes for me. Whoa, man. Woo! That'll get you in jail real quick. All right. Let's go ahead and move to this example. We almost made it, guys. We almost made it.